that time these silicons become N-type materials because antimony have 5 valence electron, 4 valence electron connect or joined or linked with silicon, on extra electron is there. That's why this is called the donor materials, or this is called the electron majority materials. So extra electron is there, that means electron is majority, and opposite is minority, that means hole is minority. Now p-type materials. So p-type materials, if we dope three valence electron materials like boron, aluminium, or gadolinium, or gallium, then these silicons materials become p-type materials because boron have 3 valence electron. That's why these 3 valence electron can link with silicon 3 electron, and one electron of silicon cannot make link with boron electron. That's why the boron part become a void. The boron part become a void. Void is there. This void is indicated. This void is indicated by positive sign or circle. So this is the p-type materials, and p-type materials. So majority of p-type materials is positive sign, and minority of p-type materials is electron, negative sign. That means majority in p-type materials is hole, and minority is in p-type materials is electron. Okay. Now these n-type materials have extra electron, and p-type materials have a negative electron. That means in hole. So now these n-type materials and p-type materials, if we joined together, then become a diode. So the simple definition of diode is the junction of n-type and p-type materials. The simple example or simple explanation of diode is the junction of n-type and p-type materials. Now, if we join n-type and p-type materials together, the junction point create a region, extra region. This is called depletion region, and the depletion region act as a barrier or resistance. The depletion region act as a barrier or resistance. So to overcome this barrier, you have to put an extra voltage or power, and this voltage is called built-in voltage. That means the voltage to overcome the barrier of PN junction is called built-in voltage, or simply you can say the voltage to on the diode is called built-in voltage or threshold voltage. This built-in voltage is fixed. For silicon diode, it is 0.7 or 700 millivolt. 0.7 volt or 700 millivolt. And fixed for germanium materials, it is fixed for 0.3. That means 300 millivolt. Okay, any questions about this N-type materials, P-type materials, or built-in voltage? Okay, the CR, the name of CR is Jawad, right?
Yes,
Yes,
sir.
sir.
Maybe Jawad.
Taronai.
স্যার ও স্যার মনে হয় অ্যাবসেন্ট স্যার।
সামিয়া নাই, সামিয়া।
Okay. So, মানে
সামিহা
second CR or third CR?
হ্যাঁ
স্যার
স্যার বলেন।
অনেক।
আচ্ছা,
হ্যালো।
অনেক
কে শোনো?
Yes, sir.
হ্যাঁ
Yes,
হ্যালো।
sir. Asif.
Help me. Please take an attendance. Take an attendance of meeting. This is not applicable for Anula University or your attendance marks. This is requirement for UGC. If they want, then we can show. So it
Thank you,
is
sir.
difficult. It is difficult for me to take the attendance. So please, you take the attendance and next you can send me.
আরে খাতায় লিখতে হবে রোল নাম্বারগুলো।
Yeah. Maybe I think the
Okay.
maximum is present, 43 present. So you can count who is not present.
Okay.
44 present. I think 44 is present. So maximum is
Samiha.
This is more than the my class, university class. Oh, that's good.
জি স্যার।
সামিয়া আছে ইয়াতে সিআর আছে।
So okay, you just
পার্টিসিপেন্ট দেখ,
জি, স্যার।
পার্টিসিপেন্ট দেখ। কে নাই ওটা ইয়ে কর।
participant is 44. I think more than 44. Now going to 45. Okay, so now N-type
স্যার একটা কথা বলতে যাচ্ছিলাম স্যার। স্যার যদি নোটপ্যাড বা হচ্ছে অন্য টাইপের কোনো কিছু ইউজ করা হয় এবং স্ক্রিনটা শেয়ার করা হয় তাহলে স্যার আমরা বেটার বুঝতে পারবো হয়তো, কারণ মুখে বললে স্যার যতটা বুঝতে পারছি না লিখলে স্যার ততটা বেশি বুঝতে পারতাম।
I shared. I use the screen share, but this is the revise for previous lecture. That's why I cannot show. Maybe from next class we will, or end of this class we will show the slide class lecture. I am also working for you. Make a new class lecture. Okay, now the diode, the N-type materials and P-type materials diode. Now we discuss about the application of diodes, especially that diode. Almost one and only applications is rectifier circuit. Diode application is rectifier circuit. So two type of rectifier. One is half wave rectifier, another one is full wave rectifier. Half wave rectifier about 41%, and full wave rectifier efficiency is about 42%, 82%. Sorry. So normally half wave rectifier is never used. Maximum place use the full wave bridge rectifier circuit. The efficiency of full wave bridge rectifier circuit is about 82. And another application of diode is clipper circuit and clamper circuit. So clipper circuit, that means the clip some input signal. That means the output output signal is less than input signal. Output signal is less than input signal. This is clipper circuit, and clamper circuit is opposite of clipper circuit. That means output is larger than input. Output signal is larger than input signal. This is clamper circuit. And another is the special type of diode is Zener diode. So Zener diode is a special type of diode. the specialty is Zener diode can work in forward bias and in reverse bias. In forward bias, Zener diode act as a silicon diode. That means in forward bias, Zener diode as like as silicon diode. But in reverse bias, it has a specific built-in voltage in reverse bias. And this is not fixed. This is variable. In our university, experiment number 4, you have done the reverse built-in voltage was 5.6 volt. So this is not fixed. This is depend on your requirement, or this is vary. The
Sir,
range no, the range of 200 to 200.
স্যার রিভার্স বায়াসেরটা আরেকবার বললে ভালো হতো।
So reverse bias, Zener diode is a special type of diode. It can work in forward bias and in reverse bias. In forward bias, Zener diode as like as silicon diode, but reverse bias, it have a specific reverse built-in voltage. For our university, the Zener diode in experiment number 4, practical experiment number 4, we use Zener diode that built-in voltage is 5.6 volt. And this range is vary. Normally 2 to 200 voltage. But our university we have the Zener diode with 5.6 built-in voltage. Okay, so this is the end of diode part. So now we can go in BJT part. So BJT, we already maybe we have taken 4 or 5 class about BJT.
একজন স্টুডেন্ট নাকি ঢুকতে পারতেছে না, ওকে ঢুকতে দিতে বলতেছে।
Sorry.
স্যার একজন স্টুডেন্ট নেট চলে গেছিল, ও ঢুকতে পারতেছে না এখন। এখন আপনাকে বলতে স্যার ওকে অ্যাকসেপ্ট করতে, আমাকে মেসেজ পাঠাচ্ছে ও। রাফি।
আচ্ছা, okay, admit maybe Maruf, right?
Yes sir.
Okay, I admit ready. Okay, so now we are going to summarize about BJT. So BJT is bipolar junction transistor, and BJT built by 2 diodes. BJT is built by 2 diodes. One diode between base and emitter, and another diode between base and collector. Okay. Now BJT working principle of BJT. BJT work in 3 stages or 3 regions. One is cut-off region, that means off region, and another one is active region. This is also on region, and another one is saturation regions, like on region. In cut-off regions, both diodes are in reverse bias. That means the emitter base junction or emitter base diode, or collector base junction or collector base diode, both are in reverse condition. Or you not apply any voltage in BJT. You never apply any DC voltage in BJT. That time the BJT is in cut-off region. Or you apply voltage is very less. That means less than 0.7 voltage. That time also BJT is in cut-off region. Or if you apply voltage, that means you apply voltage in emitter side and collector side. and you use 0 voltage in base side, that time also both diode are in reverse bias. So BJT is in off region or cut-off region. Now on region, on is active region. So in active region, the emitter base junction or emitter base diode is in forward bias, and collector base junction or collector base diode is in reverse bias. How it's possible? Like if you use base voltage is higher than emitter voltage by 0.7. The base voltage is higher than emitter voltage at least 0.7. Or you use base voltage maybe 2 voltage, base voltage is 2 and emitter voltage is 0 or emitter voltage is on. That time, and collector voltage is higher than base voltage. If base voltage 2, emitter voltage 0 or on, or collector voltage 3 or 5, that time BJT is in active region, because the diode of base emitter is in forward bias and diode of base and collector is in reverse bias. That's why BJT is in active region. And another condition, one condition is saturation region. Saturation region, both diode will be forward bias. Both diode will be forward bias. That means base voltage must be higher than collector voltage and emitter voltage by at least 0.7. That means if base voltage is 2, collector voltage is normally on voltage and emitter voltage is on voltage. That time BJT is in saturation region. So this is the 2 region of BJT. Three region: cut-off region, active region, and saturation region. Okay, any question about BJT or region? Operational region?
স্যার একটা কোশ্চেন ছিল স্যার।
Okay.
স্যার কোশ্চেনটা হচ্ছে স্যার হ্যালো
Yes, I'm hearing.
স্যার হচ্ছে স্যার কাট অফ রিজিয়নের মধ্যে হচ্ছে স্যার মানে এনপিএন জাংশন অনুসারে যদি বসানো হয়েছে, এখন স্যার মানে প্রবলেম সলভ করার সময় হচ্ছে স্যার যে মানে ডায়োডটাকে যে বিবেচিত করতে হয়, ওই ডায়োডটা হচ্ছে মাইনাস থেকে প্লাস আর প্লাস থেকে মাইনাস, অর্থাৎ স্যার যদি এটা যদি স্যার পি এন আর একটা পি জাংশন বরাবর যদি ইউজ করি, তাহলে স্যার এভিএল কেসিএল অ্যাপ্লাই করার সময় স্যার মানে তখন কি স্যার ভুল হবে?
You use KVL always base emitter and follow the direction of diode. You use KVL from base emitter and clockwise or anti-clockwise. KVL clockwise or anti-clockwise depend on the direction of diode. Follow the diode direction. That means positive to negative. Diode positive to negative.
জি স্যার, বুঝছি স্যার।
Okay, next we are going to the biasing of BJT. The biasing of BJT, maybe this is that was our last class. Biasing of BJT. We have discussed 2 type of biasing. One is fixed bias, another one was fixed bias, another one was self bias. This is experiment number 6 also. So fixed bias, in fixed bias circuit, there was no emitter resistance. And you can see when we use the KVL to base emitter, the value of emitter current is not dependent on beta. That's why if we change the value of beta, the collector current and the collector voltage will change and Q point will change, which is not acceptable. The change of Q point is not acceptable because if Q point change, the signal will lose. If the Q point change, some signal will lose. That's why we never use that circuit which have change in Q point. But in self-bias circuit, you can see there is a ammeter resistance, and when you apply the KVL through base and ammeter, we can see the ammeter current depend on beta. The emitter current depend on beta. That's why if we change the beta, emitter current will change, collector current will never change. Collector current will never change, and collector voltage, that means VCE will never change. That's why the self-bias circuit is appropriate for practical application, and self-bias circuit never change the Q point.
স্যার বায়াসিং স্যার কেন করা হয়?
Sorry?
স্যার বায়াসিং স্যার কেন করা হয়?
Okay, so the definition of biasing, that means what is biasing? Biasing is external DC voltage which is on the BJT. That means actually BJT is a amplifier circuit. BJT's applications is amplifier circuit, and the input of amplifier circuit only in millivoltage range. That means 10 millivolt or 20 millivolt, like that. And this 10 millivolt or 20 millivolt never on the diode of BJT. BJT have two diode, right? So if you want the diode, you must use 0.7 voltage. But AC signal only have 10 millivolt. This AC signal never on the diode or never on the BJT. That's why to on or to active BJT, you must use external DC voltage. This external DC voltage called biasing voltage.
স্যার এই জন্য কি স্যার রেজিস্ট্যান্স ইউজ করা হয়, মানে কন্ট্রোল করার জন্য ভোল্টেজটাকে? তো এই জন্য স্যার রেজিস্ট্যান্স ইউজ করা হয় ভোল্টেজ কন্ট্রোল করার জন্য?
Resistance, actually resistance control the current, or you can say you can control or you can divide the voltage by
স্যার
resistance.
সবসময় কি ডিসি ভোল্টেজ ইউজ করা হয়, এসি করা হয় না?
For biasing
জি স্যার, সবসময় কি ডিসি
you
ইউজ
must
করব?
use DC voltage. For biasing you must use DC voltage. You cannot use AC voltage for biasing.
স্যার তাহলে পাই মডিউল এগুলাতে দেখা গেছে যে এসি ভোল্টেজও ইউজ করা হয়েছে।
AC voltage, AC signal, not AC voltage. That is AC signal. You can see very small. In experiment number 7, when you do in experiment number 7, you apply the biasing voltage. I think the biasing voltage about 10 or 15 voltage DC, and input AC signal only 40 milliampere. So
Yes, sir.
AC always very small signal. And normally they call the small signal equivalent circuit. So small signal equivalent circuit also. It's called the small signal equivalent circuit also. The AC signal is very small. This is in milli range, 10 milli, 20 milli or 50 milli, like that. But biasing voltage is DC voltage, and it is normally 10, 15 or 30, like that. So now we are going for the lecture 17 for another type of biasing circuit. I'm going to sharing the screen. Okay. I'm going to sharing the screen. Can you see the screen? Lecture 17.
স্যার একজন